Hello, in this video I want to look at finding an annuity and looking at the cash layout of the deposits. So we have that a future value of an annuity is when you take a payment that's periodic and you multiply it by 1 plus I to the n minus 1 divided by I. Now, the things that we can say is that we know that the payment is a sequence of payments, periodic payments to be exact, and the I is equal to R over M. Now, the N is equal to M times T. And here we have that the future value that we have for this example is that you have $75,000 to be saved in 10 years at an interest rate of 6% compounded semi-annually. Now that means that the M would be equal to 2 since it's semi-annually. The T would be equal to 10, so that's going to be that N is equal to 20. But notice that for here, you have that I is equal to, well, the percentage rate of 0.06 divided by 2, which is 0.03. So what that would mean is that when we set up our question, we have that the 75,000 is going to be equal to the payment that is unknown multiplied by 1 plus 0.03 raised to the 20, and this is minus 1, and this is divided by I. Well, we don't want to use I, so maybe we'll just do 0.03, and then we'll just close this. Now notice that in order to solve for the payment, we have to multiply by the reciprocal. So basically this tells us that to do this, we have to form the computation of where we take the 75,000 multiplied by 0.03 divided by, well, in this case it's actually 1.03 raised to the 20, and that's minus 1. Okay, so in any case, if you would have gotten this computation and then divide it into 75,000, it's the same thing. So here we could probably just say alpha y equals, and we're going to put 75,000 multiplied by 0.03, and this is going to be divided by, now I got to put that in parentheses because I have that it's 1.03 and it's going to be raised to the 20th, right? Okay. And then we're going to subtract 1, and let's see what we get when we push enter. Okay. Now this is the amount of which that you're going to pay, okay? So we have 2791.18. Now, of course, if we round down, but we want to achieve the amount of 75,000, then that's a little different. Well, I mean, in that it's going to be adjusted slightly. So here, we're just going to say that this is going to be approximately 2,791.18. Okay. Now notice this though. If we want to find the interest, what we would need to do is take 20, multiply it by 2791.18, and basically we have to take 75,000 and we're going to subtract the interest that, or the contributions actually. So that should be the answer, not the question mark. So hit enter, and this is the amount of the interest that's earned over the 10 years, compounded semi-annually. So one thing that we can do is look at what if we plug this into, let's say, Excel, okay? So if we plug this into Excel, we have that this is the amount of which is the, that should say semi-annual, but that's okay. We can call that periodic payment. Why not? Periodic payment. That way it's a little more consistent. And the interest rate is 6%, semi-annual, 10 years. Okay. So the first payment is not going to earn anything because it's at the end of the period of the 6 months. So that's why it says 0. But notice this. How do I get the interest that's earned? You have to take the previous balance of, well, the 27.91 and 18 cents and multiply it by the R over M. One way that you can do that is just take, like we said, the 2791.18 and you would multiply it by I, but you already calculated that I was 0.03. This tells us that this is the amount of the contribution in any case, or the accrued interest. So 83.74 is what goes in, and that's what we have right here. Now, notice that you now have a new balance, and that new balance would have to be the sum of the previous balance plus the payment plus the earned interest, and now we have a new balance. But then you have to do that all over again. You take the current balance or the previous balance and you multiply by 3%, and this is the amount of interest that you get. So that means that you just have to add the 5,666 and 10 cents to the payment plus the interest that is earned, and now we have our new balance. If you follow along, you can see that this can be done in Excel, for example. If you were to, let's say, add these two first, then that's like you saying that that total amount is the amount that goes plus the previous balance and so on. So even if, this wasn't here, for example, let me delete that and see what happens. Okay, so I know that the payments are always going to be the same. And this is me just setting up that I took the previous balance times the I, and then that's what it gave us, right? So we drag that. And okay, yeah, it's not going to calculate just yet, but look at this. This is the sum of the previous balance plus the payment plus the interest. So in that case, it's just going to repeat for that whole cycle. And look at what happened. We have that there is an excess of 5 cents. In either case, what has to happen is that we have to take the 75,000 and we have to subtract the previous balance and the earned interest, because we see that this is the amount of interest that was earned. Then once we do that, then we can figure out what is the balance, or sorry, what is the last payment going to be. Well, hopefully you can kind of tell that it's just 5 cents, right? So there we go. We have that the last payment is going to be 5 cents less. But note that if you had increased anywhere these payments, like what if you told yourself, well, I can afford to do like 2,800. Why not? It's not that far off, right? And then from there, you would have to essentially update these in either case. But see like how we're over, and we're over by $221. That's not a big deal. Of course, you can always adjust this last payment, right? It's just $221.58 less in that case. So, when we look at this, check this out, we see that this is the amount of which that was contributed, and that's that 55,000 that we saw earlier. But then over here, if we go ahead and we add up the interest, we see that this is the same amount that we got with the interest in total. Of course, we have to have that this has to add up, and I think right now that might not be adding up properly, but that's okay because it's just because of rounding more than likely. Let me see if I fix that. Let's see what happens if we put the 18. Let's change this one. Let's see if that does anything. Let me do this. Okay, hang on. Okay, so we need to add the interest. Why did it do that? Okay. Okay, there's the interest. And 2791.18. Oh, there we go. So you can see that when we add these two, that this is the 75,000 that we would get. Now, in actuality, you could probably put this in Desmos and see that the amount starts from 0 and that it will reach exponentially the amount of the 75,000. But having to track the specific balance at a particular moment in time can be a little bit tedious in either case. But you can see that through this spreadsheet that we're able to actually track exactly the amounts of which that we have at every single period during the annuity in either case. So this tells us that if we wanted to know perhaps like when it reaches 51,000, well, we have that it happens around the 14th and 15th payment, which basically means that 7 years, at least 7 years, have already passed. So we could say that it's at least 7 years when the amount reaches 50,000. Would you want to take it out at that point? Well, that's up to you, actually.